We will now calculate the rocket equation. We start with Newton's second law, which states that the force is equal to the change of the momentum per unit time, dp dt, where the momentum p is equal to m times v, the mass times the velocity. Here we have a rocket going upwards with a velocity of v relative to the Earth and with a mass of m. We choose positive direction to be upwards from the Earth. After a small time step dt, this rocket has accelerated to a new velocity of v plus dv. But in doing so, it has to consume some of its mass, so the mass of the rocket has decreased by a small amount, the m, which is negative. This mass will come out as exhausted gases with the velocity relative to the Earth of v prime. Now we can calculate the change in momentum. The initial momentum P E is equal to m v, and the final momentum Pf is equal to the momentum due to the rocket, m plus dm, times v plus dv, plus the momentum due to the exhausted gases, dm, times v prime, where the m is negative, so we have to have a minus sign before the m, in front of the m. If you calculate this and we neglect the small quantity dm times dv, we get m v plus m dv minus v prime minus v times dm. But the velocity of the exhausted gases relative to the Earth, v prime, minus the velocity of the rocket relative to the Earth, is equal to the velocity of the exhausted gases relative to the rocket, ve. Now we can write these two expressions and subtract them from each other to get the change in momentum. The initial momentum P initial was m v, and the final momentum will then be equal to mv plus mdv minus v e dm, and the change in the momentum dp will then be p final minus p initial, and that will be mdv minus v e dm, and the change in momentum per unit time dp dt will then be m dv dt minus v e dm dt, but this is equal to the external force, which is here the gravity mg. Here we neglect the air resistance and the variation of the gravity with altitude, so we let this be a constant. If you instead use scalars, then in scalars minus g, because the vector g is pointing in the negative direction, and that will be dv dt plus v e over m dm dt. Now we multiply this by dt and integrate, so we get minus dt is equal to integral of dv plus v e over m dm, and we integrate from time to equal to, from 0 to t. The initial velocity will be v naught, and the initial mass of the rocket m naught. If you do this integration, we get that the final velocity v is equal to the initial velocity plus the velocity of the exhaust gases relative to the rocket times ln initial mass divided by the mass at time t minus gt, and that is the rocket equation.